Hi there, Charger family. This is Mrs. Boyd. Today we're going to talk about inequalities in two variables, graphing an inequality that involves two variables on a coordinate grid instead of a number line. Let's get into it. When graphing an inequality in two variables on the coordinate plane, we follow the same procedure as graphing an equation with two exceptions. The line can be solid or dashed, and we need to shade a region of the graph. The shade portion that's right here is what everybody forgets to do. Don't be that guy. Here we go. So if we've got a less than or a greater than, no equals involved, that's an open circle on a number line, right? On a coordinate grid, it's a dashed line. What that means is that the numbers along the line are not included in the solution, or the number on where the circle is not involved in the solution. Let's graph this first set of solutions here. -3, 2. Oh, this is our line. Y is less than X. Well, Y equals X. Let's start out like that. Is a line that splits the first and the third quadrants in half. And we want Y is less than X. If we have graphed Y equals X on our coordinate grid, like we've done here, and we have our Y variable on the left, this inequality sign here tells us which way to shade. If it's a less than sign, like it is here, we're going to shade below the line. All right, so we shade down here. And it does not have to be a solid shading. It does have to show me which side is shaded. So which one of these points is a solution? -3, 2. We have 1, 2, 3, up 2 is right here. That is not a solution. Solutions are going to be in the shaded area. 0, 0, right there. The line is dashed, so 0, 0 is not a solution. 2, 1, right? 2, up 1. Definitely in the shaded zone. 2, 1 is a solution. Let's do the same thing for Y is greater than X. We're going to think about graphing Y equals X again. So whatever Y equals, X also equals it. It's a dashed line because there's no equals in our inequality. And it's greater than. Y is greater than X, so we'll shade above the line. Now let's test and see if any of these points are solutions. -3, 2, 3 left, 2 up, right there, definitely a solution. 0, 0 on the dashed line, no solution. 2, 1 below our shaded area, also not a solution. All right, so that's kind of the bare bones of dashed line inequalities. Let's look at the ones with an equals involved. If a no equals is a dashed line, then anything that includes the equals as bar below is going to be a solid line. This is like a dot on a number line, where it'd be filled in, and those values are also included. All right, so same thing applies. We've got Y equals X. So 1, 1, 2, 2, 3, 3, except now we have a solid line that splits our coordinate grid in half. And this is y less than or equal to x. We're going to shade below. Let's see if any of these points are solutions this time. -3, 2, 3 left, 2 up, not a solution. 0, 0 at the origin is a solution because now that our line is solid, numbers on that line are also included in the solution. 2, 1, also a solution. Let's check out the last one here. Same line we've been drawing, except for it's solid this time, like we said. And it's greater than, so we're going to shade above. Let's check our points. -3, 2. Right there, all definitely a solution. 0, 0. Definitely a solution. 2, 1, not a solution. You can see it's important to not shade in super solidly because if you do, you won't be able to see where points are in your solution zone to check and see if they're correct. So that's kind of the bare bones of how you graph an inequality in two variables. Let's work on some more of these. Graph the inequality on the coordinate plane, then circle all possible solutions to the inequality. These first three are pretty straightforward. They're all in slope-intercept form. So y is less than 3x minus 2. If this is y equals 3x minus 2, let's plot our points on the line first. The y-intercept is -2, so we go down 2. The slope is 3, so from this point, we go up 3, right 1. Or down 3, left 1. There is no equals in our inequality, so this line will be dashed. And now we can see that it's less than, so we shade below, which in this case is kind of to the right because it's tilty kind of to the right. Let's check these points for solution possibilities. -3, 2, 1, 2, 3, 1, 2. Not a solution. 0, 0. Not a solution. 1, 4. No, sir. 2, -5. Yes, it is a solution. There's our first winner. Next, 0, -2. Not a solution along the line, but our line is dashed, so it doesn't count. Next, -4, -2. No. 2, 2. Yes, that is a solution. -2, 3. No. And lastly, 3, 0 is a solution. So we've got 3 points that are in our solution zone. Half the battle here is shading in the right direction. I know you can totally do it. Let's do another one. We can imagine this is y equals -2/3 x plus 4. Our y-intercept is 4, so we go up 4 on the y-axis. And then slopes -2/3, so down 2, right 3. There is no equals in our inequality, so this will be a dashed line again. And since it's less than, we'll shade below. There it is. Now, I want you to test on your own and see which of these points are solutions. Got -3, 2. Yes. 0, 0 is a solution. 1, 4. Not a solution. 2, -5. Yes. 0, -2. Yes. -4, -2. Yes. 2, 2. Looks like it is in this case. Sorry, technical difficulties there. -2, 3. Definitely included. And then 3, 0. Yes, also included. So only one here, not included in our solution zone. Let's try again. This time we have y equals -4 if it's an equation instead of an inequality. So y is -4. If you'll remember, we can put it in a table, and no matter what x is, y is -4. So 0, -4, 1, -4, -1, -4. And this is a dashed line. And if it's greater than -4, which it is, we'll be shading above. Let's test our points and see what's what. -3, 2. I'm just going to tell you which ones are solutions because it'll take a minute. I want you to try it on your own. Pause here and then come check your work. So it looks like the only one of these not a solution is 2, -5. And the rest are winners. Let's try a few more, then we'll call it quits. Got a standard form equation here. 2x plus 3y is 6. Let's use our knowledge of intercepts to graph this inequality. We've got for the x-intercept, it'll be 2x equals 6, or x is 3 is our x-intercept. And then for the y-intercept, 3y plus 6, or 3y equals 6. So y is 2. There is an equals included in this inequality. So this is a solid line instead of a dashed one. And it's less than, so we will be shading below. Pause here, test your points, come back and check your work. The only points here that are not included are 1, 4 and 2, 2, but everything else is a solution. Lots of solutions there. Next inequality, we can imagine this one's y equals 3/2 x minus 1. So our y-intercept is -1, and the slope's 3/2. So up 3, right 2. Or down 3, left 2. There is an equals included here, so this will be a solid line. And we shade above because it's greater than. Pause here, test your points, tell me what's the solution. We got 3 no solutions, 2, -5, 0, -2, and 3, 0 are not solutions. All of the rest of these are. All right, it's the last one. Got x equals -2, or x is greater than or equal to -2. Remember, if we make a table of values, no matter what y is, x is always -2. So we've got -2, 0, -2, 1, -2, -1. This includes an equals, so it'll be a solid line. And it's greater than when we have a vertical line. It's just like a number line. So our inequality points in the direction that we'll be shading to the right. So pause here and see, test your points and let me know which ones you get. All right, only 2 not solutions here. -3, 2, and -4, -2. Those are only not solutions. I hope this is pretty clear for you. This is nothing like you've done before. So I hope you're doing well. I hope if you have questions, you let me know and reach out. And I hope to see you soon.